So we're going to solve polynomials today, and we need to think back to some techniques that we have for solving, especially quadratics. Do you remember any of them?
Probably.
Probably the most useful is factoring. When we factored, our another good technique was graphing.
Yes.
Then we did the quadratic formula. And finally, in solving quadratics, we completed the square. The quadratic, as you're still writing those down, the quadratic is a polynomial of degree 2. And since it's degree 2, how many roots or solutions or zeros will we have to that function? Well, degree 2 means at most we'll have 2 solutions. If it were degree 10, we'd have 10 solutions. If it were degree 50, we'd have 50 solutions. The degree will define how many solutions we're going to have. But what we're going to focus on here for a few minutes is we're going to solve by factoring. And our first method here for our problem x squared minus 49 is the difference between two squares. The difference between two squares means that we're going to take the square root of x squared, we're going to take the square root of 49, and then we're going to have different signs. So the square root of x squared is x, the square root of 49 is 7. The difference between two squares, different signs. But we're going to solve these. So when we solve, we're going to take x minus 7, and set it equal to 0. And x plus 7, and set it equal to 0. So we're going to add 7 to both sides. We get x equals 7. We're going to subtract 7 from both sides. We get x equals negative 7. Now there's many of you that don't have to even write that. You can write your factoring steps down, and then you can write your roots down. Do notice that this is a quadratic to the second degree. That means that we're going to have 2 solutions in this problem, and our 2 solutions are 7 and negative 7. What we should always be asking ourselves when we're solving a quadratic is, 1, can it be factored? And 2, if it can be factored, do we have a greatest common factor? As we take a look at this problem, the answer to both of those questions, can it be factored? Yes. Is there a greatest common factor? Yes. And in this particular case, our greatest common factor between 8 and 24 is 8. Between n squared and n, it's the smallest exponent, which is n. When we factor out the greatest common factor, what we're left with then is determined by taking 8n squared divided by 8n, which is n. And 24n divided by 8n is 3. And once we get the polynomial factored, just like the previous problem, our highest exponent here is a 2. It means that we're going to have 2 solutions. And some people can go directly from the factoring to the solutions. If you are not one of those people, we're going to take 8n equal to 0. We're going to take n plus 3 set equal to 0. We're going to divide both sides by 8. So we get n equals 0. Over here, subtract 3 from both sides, and we get n equals negative 3. And those are our 2 solutions, 0 and negative 3. Again, when we're looking at quadratics, we should certainly always ask, can this be factored? And then we ask ourselves, well, do we have greatest common factor? Well, yes, we can factor. No, we don't have a greatest common factor. And this is a trinomial. And we can split the middle on this particular problem. When we start that, it's going to be 4 times 3, which is 12. And the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. The question is, will any of those combine to be 1? And what we see is this last one here, the 3 and 4, will combine to be 1. In fact, if we get a little bit more specific, we want it to combine to be negative 1, which means that this has to be 3 minus 4. So it's 4x squared, and then it's going to be minus 3. I wrote right on top of it there. I'll scoot that over if I can, minus 3. And then when we put this back in, it doesn't matter which order we put it back in. It might be a little bit easier if we do minus 4x plus 3x. We split the middle. Now we're going to group. When we group, part of that's going to be greatest common factor. In our first group, the greatest common factor is 4 between the numbers. Between x squared and x, it's the smallest exponent, which is x. 4 divided by 4 is 1. X squared divided by x is x. Sometimes what we say is we had 2 x's. We take out 1, so we only have 1 left. Then over here in the next term, 4x divided by 4x is 1. We had 1x, we took it out. And again, 4 divided by 4 is 1. And in general, especially with grouping like this, what we get in the first group is what we're going to get in that second group in terms of the parentheses. GCF is 3. 3x divided by 3 is x. 3 divided by 3 is 1. And sure enough, we've got an x minus 1 in the first group and an x minus 1 in the second group. So x minus 1, 4x plus 3. Again, there may be some of you that can still come up with the answers, and certainly one of them is easier than the other. But it's solving a quadratic, so we do want 2 solutions. And I want to point out, again, quadratic to the second power. We can take x minus 1 and set it equal to 0. We can take 4x plus 3 and set it equal to 0. And we can add 1 to both sides. So we get x equals 1. And we can subtract 3 from both sides. We get 4x equals negative 3. And divide both sides by 4. So x equals negative 3/4. So we've got 1 and negative 3/4 for our 2 solutions. Those are quadratics. 2 solutions. So now, how can we use these techniques to solve higher order polynomials? And today what we'll finish with is solving cubic polynomials. And if you think about what cubic means that the degree is 3. And consequently, because the degree of the function is 3, how many roots or solutions or x-intercepts do you think we'll have? 3. Once again, when we look over here, the highest degree is 3 on this. So eventually, what's going to happen is that we are going to have 3 solutions to this problem. And factoring is still a good technique to use if we can. So as we take a look at this, the first thing to ask ourselves, and I'm going to erase this because it's kind of in the way, but do we have a greatest common factor? And we do. There's an x in each term, so let's factor out an x. And when we factor out an x, we're left with x squared. We had 3 x's, we took out 1. Minus 3x. We had 2 x's, we took out 1. Minus 4, we had 1x, we took it out. now we're going to split the middle. It's 1 times 4 is 4. And the factors of 4 are 1 and 4, or 2 and 2. And will either one of those combine to be 3? Well, yes. 1 and 4 here. In fact, it's going to have to be 1 minus 4. We've got x squared and the minus 4. And then we can say plus 1x minus 4x. And we'll go to our grouping technique. Here and here. And when we factor out, we're going to factor out an x. We're going to be left with x plus 1. Over here, our greatest common factor in our second group is a 4. Be careful with that minus in front. But it's negative 4x divided by negative 4, which is x. Negative 4 divided by negative 4 is positive 1. What we see in our groups here is that we have x plus 1 in the first group and x plus 1 in the second group. We have x plus 1. Then we have our x minus 4. And don't forget at the very start, we factored out an x. And once again, there's some of you who can go from here and say the answers x equals 0, or x equals negative 1, or x equals 4. But if you're not one of those people, that's okay. All that we do, we take x and we set it equal to 0. We take x plus 1 and we set it equal to 0. We take x minus 4 and set it equal to 0. So we're going to subtract 1 for both sides. We get x equals negative 1. We're going to add 4 to both sides. We get x equals 4. It's a cubic polynomial. So therefore, we should have 3 answers. 1, 2, 3. And hopefully I wrote them correctly up there. Personally, I like this. I like reinforcing the idea behind factoring as a very, very useful technique to help us when we solve. And as we take a look at letter B, the question is, can we factor this one? And we're hoping so. A reminder, this is a cubic polynomial. It's in standard form. And what we see is that the highest exponent in this problem is a 3. And consequently, that means that we're going to have 3 solutions to this problem. When we do work with this one, we don't have a greatest common factor. So what we're going to do is we're going to factor by grouping. And that was just a part of what we did on that last problem a moment ago. If we break this up into 2 groups, what we see in our first group is that the greatest common factor is x squared, the smallest exponent. We had 3 x's. We took out 2, so we still have 1. We had 2 x's. We took them all out, so we still have a 5. When we look at our second group, our greatest common factor is 3. 3x divided by 3 is x. 15 divided by 3 is 5. And we've got an x minus 5 and an x minus 5 in both groups. And then we have x squared plus 3. And this one might take a little bit more work. Some of you who haven't had to do any extra work might have to on this particular problem. We're going to take x minus 5. We're going to set it equal to 0. We're going to take x squared plus 3. Set it equal to 0. Once again, a reminder. Cubic means that we're looking for 3 solutions. And then we add 5 to both sides. There's one of them. There's 1. I need 3. And this next one, what we need to do to solve is we need to subtract 3 on both sides. We get x squared equals negative 3. And then what we have to do is we have to use our undoing process here for squaring. And when we undo that, we are going to take the square root of both sides. On the left, we're left with x. On the right, this is the square root of negative 1 times the square root of 3. What does the square root of negative 1 equal? Again, the more you can say it out loud, the more you're going to remember it. So we're going to get I times the square root of 3. The other thing that we need to remember is that positive times positive is positive, and negative times negative is also positive. We need to take into account that this answer could be either positive or negative. And that's where the other two roots are. I am fine with you writing plus or minus I radical 3. But when I come up here, I'm going to write it as I radical 3 and negative I radical 3. For people who are very literal, and that means I said 3 answers, well, show me all 3 of them. 5 is an answer, I radical 3 is an answer, negative I radical 3 is an answer. Flipping our paper over, we've got the quadratic formula back here. But once again, always ask yourself when you're approaching solving a polynomial, can it be factored? And sometimes the answer is going to be yes, and sometimes the answer is going to be no. But luckily enough on this particular problem, it also can be factored. But before I get going too far on it, I want to point out the fact that this is a cubic polynomial. So eventually what we're going to be looking for is we're going to be looking for 3 solutions. I'm going to erase that circle over here, just because it gets in the way. Then ask yourselves, do we have a greatest common factor? We've got a greatest common factor. And not only is it an x, it's also a 2. 2 is an even number. 10 is an even number. 12 is an even number. Because those are all even, we can factor out 2x. And that means we're going to be left with x squared plus 5x plus 6. 2x cubed divided by 2x. We had 3 x's, we took out 1. We've got 2 left. 10x squared divided by 2x. We had 2 x's, we took out 1. 10 divided by 2 is 5. 12x divided by 2x. We had 1 x, we took it out. 12 divided by 2 is 6. Now that we get this, we can split the middle. And it's 1 times 6, or 2 times 3, for our factors. And the thing about these is that both of them can combine to be 5. So it would have to be negative 1 plus 6, or positive 2 plus 3. And if we take a closer look at the problem, we know that we want to pick the second choice because we don't have any negatives in the problem. So we can't put 1 in. So we're going to split the middle. We've got x squared plus 6 here, and then plus 2x plus 3x. And here's a group, and here's a group. Greatest common factor between x squared and 2x, just x. And then we're left with x plus 2. In our next group, it's going to be 3 times x plus 2. And what we see is that we've got an x plus 2 in both groups. And we have an x plus 3. We also have a 2x. Once again, some of you can tell me x equals 0, x equals negative 2, x equals negative 3. That's fine. If you can't, where did they came from? 2x equals 0. x plus 2 equals 0. X plus 3 equals 0. When we divide both sides by 2, we get x equals 0. When we subtract 2 from both sides, we get x equals negative 2. And when we subtract 3 from both sides, we get x equals negative 3. 0, negative 2, negative 3. Our last problem today, 8x cubed plus 27. We're going to have to factor a cube. And we oftentimes get practice in and out of greatest common factor, factor by grouping, split the middle. But we don't very often get extra practice on the factoring cube. So this is something that may need refreshed in your mind. When we taught it way back in August, what we did is we used this technique called SOAP. So when we start with this, we're going to turn the problem into a binomial, 2 terms, and then 3 terms here. And to get the first parentheses, we're going to be taking the cubed root instead of like we did on our very first example today, the square root. And the cubed root of 8, you could type that into your calculator. But some people just ask themselves, what times what times what? 3 of the same, that's going to equal 8. Well, 2 times 2 times 2 is 8. It's going to be 2, and the cubed root of x cubed is x. Same thing with 27. We want the cubed root of 27. Well, what times what times what equals 27, and it has to all be the same number. 3 times 3 times 3 is 27. So we're going to put the 3 in there. And here's where the SOAP comes in. So it stands for same sign. Same sign. Opposite. There's the O. Opposite sign. AP. Always positive. And now what we're going to do. 8x cubed divided by 2x. 8 divided by 2 is 4. X cubed divided by x is x squared. If you prefer, we had 3 x's. We took out 1. We still have 2. I'm going to go to the very last term here. 27 divided by 3 is 9. Where that 9 went. 27 divided by 3. We already have the signs in the problem. So our last part is 2x times 3 is 6x. And we have factored. Well, we're going to take the 2x plus 3. We're going to set it equal to 0. And then we're going to take the 4x squared minus 6x plus 9 and set it equal to 0. And we can subtract the 3 from both sides. Get 2x equals negative 3. Divide both sides by 2. And there's one of our roots. We just factored a cube, so eventually what we need are 3 solutions. And we just found one. Negative 3 halves. The next part. The 4x squared minus the 6x plus 9. When we factor a cube, that part will not factor. And that's why we have the quadratic formula here on your notes, to refresh our memory with that. But one more time I want to say, 4x squared minus 6x plus 9 will not factor. And that happens when you're factoring a cube. If that happens, we're going to have to use the quadratic formula at some point. So when we take a look at this here, A is 4, B is negative 6, C is 9, and we're going to fill that into the quadratic formula. So x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Be careful if you're typing anything in your calculator, especially that -6 squared. You must have parentheses when you're typing it in the calculator. So we have double negative here on the first 6, and double negative means that we're going to have a positive here. It's going to be 6 plus or minus -6 squared, which is 36. 4 times 4 times 9 is 144. And then 2 times 4 is 8. We simplify a little bit more, and we get 6 plus or minus, well, 36 minus 144 is -108 divided by 8. And we're close now. We have to simplify the radical. And then to top it off, within that radical, set the square root of -1. Good news is you've already told me today that the square root of -1 equals r. So what we need to deal with more so is the square root of 108, which is 2 times 54. It's not the only choice. Then 54 is 9 times 6, which is 3 times 3, and 3 times 2. And if I write that a little bit better, it's 2 times 2 times 3 times 3 times 3. Because when we simplify the square root, what we're doing is we're looking for 2 of the same value to take out 1. Well, we've got 2 2's. We can take out one of them. We have 2 3's. We can take out one of them. We still have this single 3 there. And don't forget that originally we had the square root of -1, which is the I. So we're going to put that value back in there. This is going to give us 6 plus or minus. 2 times 3 is 6i, radical 3, divided by 8. When we simplify this, and we can, 6 and 6i and 8 are all even numbers. So if we divide 6 by 2, we get 3. If we divide 6i by 2, we get 3i. And if we divide 8 by 2, we get 4. And once again, if you prefer, you can write that as your final 2 solutions. But for literal people, it says 3 solutions, so what are those 3? I'll write them out separately. It's 3 plus 3i, radical 3 over 4. Just check my answer there. And then it's 3 minus 3i, radical 3 over 4.